Hi, I'm Aghil. In this course, which includes several sessions, I will explain the structural designs of bridges with help of CSIBridge. All students, engineers, and companies can contact me in this way: Askari @yahoo.com. Also, you can connect me with LinkedIn Aghil Askari. Okay, as we all know, today we use computers and their software to do everything easily. We civil engineers must also use our own software. I use a strong CSIBridge software for structural design of bridges and suggest that you use this software as well. But I emphasize that dependence on software is not a wise thing to do because we engineers have to make decisions through our own minds. I believe that nothing in the world can fight the human intellect. So be strong and only use software to speed up your work. Okay, session 1. In the first stage, we must be familiar with the types of bridges. Different bridges have been built with different types in the world, but I believe that there are different bridges of different types that have not been built yet. These bridges are waiting for you to present them to the world in your designs. In this section, I want to introduce you to the common types of bridges. When I say bridge types, I mean their structure type, because bridges can be categorized in different ways. For example, appearance or dimensions or use, and etc. Okay, we want to see common bridge types. The 7 main types of bridges are beam bridge, truss bridge, cantilever bridge, arc bridge, tied arc bridge, suspension bridge, and cable stayed bridge. I use this site to have them in this PowerPoint. Okay, I start with the first type, beam bridge. A beam bridge is one of the simplest types of bridge. The deck area traditionally consists of wood, plank, or stone slabs. These are supported either side by 2 beams running between abutments or piers. Very often you will find other beams positioned in between the main beams, offering additional support and stability. The area over which people or vehicle travel will be a simple decking positioned vertically across the underlying beams. This is often referred to as a simply supported structure. Simply supported. There's no transfer of stress which you see in arc structures and other types of bridges. This type of bridge can be composed of different components such as beam, slabs, columns, supports, and so on. We will deal with this issue in more detail in the future. You can see some examples here. Here is a beam bridge. If you have a beam bridge in your place of residence, tell us its name and location in the comments. Thank you. Here is a beam bridge too, but previous have a big deck in the bottom of bridge and this one have beam and deck in the bottom of bridge. Okay, let's go on to the next type, truss bridges. The truss bridge has been around for literally centuries and is a load-bearing structure which incorporates a truss in a highly efficient yet very simple design. You will notice an array of different variations of the simple truss bridge, but they all incorporate triangular sections. The role of these triangular elements is important because they effectively absorb tension and compression to create a stress structure able to accommodate dynamic loads. This mixture of tension and compression ensures the structure of the bridge is maintained and the decking area remains uncompromised even in relatively strong winds. The design of this type of bridge may be a bit tedious, but the end result is really heartwarming. You can see some truss bridge here. You can see the tension and compressions elements in this bridge. Okay, next one is cantilever bridge. When the first cantilever bridge was designed, it was seen as a major engineering breakthrough. The bridge works by using cantilever, which may be simple beams or trusses. They are made from pre-stressed concrete or structural steel when used to accommodate traffic. When you consider that the horizontal beams making up the cantilever arm are only supported from one side, it does begin to sound a little dangerous. However, the two cantilever arms are connected by what is known as the suspended span, which is effectively a centerpiece which has no direct support underneath. The bridge load is supported through diagonal bracing with horizontal beams as opposed to typical vertical bracing. Extremely safe and very secure, the design of cantilever bridge is one which still lives on today. You can see cantilever bridge here. What a beauty bridge, isn't? Okay, let's move on to the next, arc bridges. There are many different types of arc bridge, but they all have central elements in common. Each bridge has abutments which are used to support the curved arc structure under the bridge. The most common type of arc bridge is a viaduct, a long bridge made up of many arcs. The lateral pressure created by the arc span is transferred into the supporting abutments. It is therefore essential that these parts of the bridge remain solid, intact, and well-founded. You will see many arc bridges with decorative brickwork, which is an integral part of the design. Simple yet so very effective, an arc bridge can carry everything from pedestrians to heavy rail. Here is an arc bridge. It made about 100 years ago in Iran. Okay, next one is tide arc bridges. What is tide arc bridge? The tide arc bridge is a fascinating design which incorporates an arc structure supported by vertical ties between the arc and the deck. The tips of the arc structures are connected by a bottom cord. This acts in a similar fashion to the string of a bow. The downward pressure from the arc structure to the deck of the bridge is translated into tension by the vertical ties. Many people assume that the abutments ensure that the tied arc bridge and arc structure stay in place. However, it is the decking strengthened cord which connects the tips of each end of the arc together. The best example of this is a bowstring which absorbs pressure, keeping both sides of the bow in contact until it eventually flattens out. You can see a tied arc bridge here. Do you know where is that? If you know, comment it. Thank you. You know, this is vertical elements that help the deck stability. Okay, we continue with suspension bridge. Suspension bridges, you can see animation of this. Okay, the structure of a stereotypical suspension bridge looks very simple, but the design is extremely effective. The deck of the suspension bridge is the load-bearing element of the structure. This is held in place by vertical suspenders which support the cables. The suspension cables extend out beyond each side of the bridge and are anchored firmly into the ground. It will depend upon the size of the bridge, but a number of towers will be installed to hold up the suspension cables. Any load applied to the bridge is transformed into tension across the suspension cables, which are the integral part of the structure. As there is some give in the suspension cables, this can translate into slight but measured bridge movement in difficult weather conditions. You can see a suspension bridge here. Oh, what a famous bridge! All of you know this bridge. You can see this bridge in all of my PowerPoint and the left of the screen. Yes, it's Golden Gate Bridge. It is a suspension bridge. I think a lot of people like me like the look of these types of bridge, but I love them. Okay, let's move on to the last types of bridge, cable bridges. Cable stayed bridge or cable bridge is different from suspension bridges. It is wrong. I should write cable stayed bridge. Please notice that. I should write here cable stayed bridge. It's not suspension bridge. Please notice, it's not cable stayed bridge. It's not suspension bridge. It is cable stayed bridge. It is different from suspension bridge. It is suspension bridge and it is cable stayed bridge. A cable stayed bridge is dependent upon towers or pylons, which are the load-bearing element of the structure. Cables are connected from the pylons to the deck below, either directly from the top of the tower or at different points of the column. When connected at different points of the column, this creates a fan-like pattern. This is the feature many people associate with cable-stayed bridge. This type of structure tends to be used for distance greater than those achieved with cantilever bridge, but less than a suspension bridge. One of the main issues with this type of bridge is that the central connection of the cables can place horizontal pressure on the deck. Therefore, the deck structures need to be reinforced to withstand this ongoing pressure. Suspension bridge and cable bridge may look similar, but with a simple glance you can see that there are major differences. You are civil engineer, you are not a regular people. You should know difference between suspension bridge and cable bridge. The members of suspension bridge apply vertical force to the deck, while the cable bridges, as mentioned, also have horizontal force. Thanks to this site, I suggest you help this site to see types of bridge. Okay, now that we know about bridge types in general, a big question arises. I want to design a bridge. Which of the above types should I choose? This is an important question. Which of the above types should I choose? To answer this question, I must say that the choice of the type of bridge depends on many factors. We have to look at all the factors and finally choose one of the types of bridge we talked about. What are these factors? 1. Location of bridge. A team of researchers must go to the site where the bridge is to be built. This group should tell you what I'm saying now. At the first, its topography of the site, entrances and exits, distance at which the bridge should be located, suitable position for the foundation and piers of the bridge. As a designer, I need to know where I am allowed to lay the foundations of the bridge. And the next is the environment. I need to know the type and amount of vegetation in the area so as not to harm nature. We should help environment about us. Okay, next one. Location of current and old rivers. We all know why we need to know the location of current rivers, which is very simple. But why the location of old rivers? If I want to tell you simply, because if a flood occurs in a place, it moves along the old rivers. Please notice, if a flood occurs in a place, it moves along the old rivers that may not be traced today. Unfortunately, in some parts of the world, urbanization has taken place on the site of old rivers. This is one of the major causes of death after floods. So we do not make this mistake. Let's go to the next one. It's the state of the sea waves. If a bridge is built at sea, the waves of the bridge should be examined. The height of the waves, the speed of them, and the force exerted by them will affect the calculation. Okay, what is next one? It's geotechnical and seismic studies. One of the important factor. Geotechnical studies determine soil type, groundwater level, shear wave velocity, seismic information, and so on. These items are very helpful for us in design. And it's the last one factor from location. Available materials. Yes, as a designer, I need to know what materials to use so that we do not have problems during execution. For example, in humid weather, it is better not to use steel materials. It's so important. And let's go to the next factor. It's bridge use. Yes, bridge uses. We need to know why this bridge is being built. This will affect the loading phase of the bridge. For example, it is a car bridge or it's a footbridge. There is so many differences between them. It will affect the loading phase of the bridge. We will work on this in the next session. Okay. You can see it's a car bridge, yes, and this one is a footbridge. There is so many differences between two of them. Let's go to the next one. Yes, beauty of the bridge. Beauty of the bridge. In addition to doing numerical calculation, you should also pay attention to the beauty of your work. Say this bridge. What a beauty bridge. You are a civil engineer, but you should pay attention to the beauty. And the last one is economy. Yes, maybe you do not accept my words, but the word moves on money. When you go to a restaurant, you may be able to order tastier food, but these food are more expensive. You can order more beautiful clothes when you go to the clothing store, but they are heavier. Everyone buys as much as they can afford. The same is true of bridge design. But I always say one sentence. A structural design is like a race. Everyone should design the structure in such a way that is strong against the incoming loads. But the winner is the one who designed the structure cheaper. Yes. Always try to design a structure cost effectively. Always try to design a structure cost effectively, please. If you want to be winner. Okay, let's try to loads. A lot of loads are applied to a bridge. It is better to have a general acquaintance with them. These are common examples of loads, but in the next sessions we will deal with each in detail. I suggest you read the complete and lovely book to use in design, Ashto. Yes, loads are dead, live, wind, seismic, impact, longitudinal forces, centrifugal forces, buoyancy effect of water current, and other. And this is Ashto. Please read this lovely book. Okay, thank you for watching the first session. I'm very happy to be able to help you become a professional bridge designer. Write your comments. Do not forget to subscribe. Please subscribe. Email cooperation if needed. Contact me by email. I will back very soon with the next session. Bye.